Welcome to our presentation, Interpreters. An interpreter is a computer program that in computer science allows instructions written in programming or scripting languages to be executed directly by computer without first needing to be translated into a machine language. In programming, we can execute program in two ways. Firstly, through compilation, secondly, through an interpreter. Here the source code is compiled into a machine code and finally the output is gained while using the compiler. And while using the interpreter, the source code is interpreted and the output is gained. The following tactics are typically employed by interpreters to carry out programs. It can work in three ways: execute the source code directly and produce the output, translate the source code in some intermediate code and then execute this code using an internal compiler to produce pre-compiled code, then execute this pre-compiled code. Now let's see the types of interpreter in programming. First one is bytecode interpreters. Here the source code is firstly converted into a bytecode, which is a compressed and optimized representation source code. The bytecode interpreters then execute this compiled code. Here both compiler and interpreter are used. Second one is threaded code interpreters. They use pointers. Each word acts as a pointer. This pointer prints to a function or a sequence. And the third one is abstract syntax tree interpreters. Here the source code is converted into an abstract syntax tree. And the last one is self-interpreters. They are special type of interpreters. Here the programming language interpreters written in a programming language that can interpret itself. Now let's move to the advantages and disadvantages of interpreters. As you can see, interpreters executes line by line, hence debugging is easy, and no intermediate code hence uses the memory efficiently. As interpreters execute line by line, it takes more time, which is a disadvantage. Java, Python and Ruby are interpreters of different programming languages. Interpreter introduced to convert high-level language into a machine language and to avoid problems with usage of compiler, such as high memory consumption and difficult in debugging process. If we take the high memory consumption, compiler generate intermediate code which is known as an object code which require memory for object code, and here the storage was a limited factor at early computers, so interpreter was introduced and it do not generate source code. This is a solution for high memory consumption and difficult in debugging process. Compiler compiles source code entirely even if there are errors, and it could lead to system crashing and fill up the memory. It generates error messages of end of compilation, and developer has to find out where the bug is. As a solution for this, interpreter interprets source code line by line. So when there is an error, it stops interpretation process and show up a error message. Now let's see how we can differentiate interpreter and compiler. Many languages require to translate program into a form that machine understands. So interpreter and compiler are used as assembler which do translation. In compiler takes entire program as an input and interpreters takes single instruction as input. An intermediate object is generated in compiler where in interpreter no intermediate object code is generated. Conditional control statements for compiler are executes faster, and in interpreter conditional control statements execute slower. Memory requirement is more in compiler while in interpreter, memory requirement is less. Program need not to be compiled every time while using the compiler, but in interpreter, every time higher level program is converted into a lower level program. Errors are displayed after entire program is checked in the compiler, and in interpreter, errors are displayed for every instruction interpreted if any. Uh, Examples for the compiler are C, C++, and Java, and for the interpreter Python, PHP, Perl, Ruby. Recent advancements in interpreters. Machine translations. These are computer-generated translators that can translate large chunks of text without any human involvement. Translation apps. These days, various mobile applications provide cheap and fast translations. Translation memory is a computer-based feature that serves existing human translations so they can be reused in future translations in order to improve the accuracy of professional translations. And as the last one, smart devices. Interpreting technology has come a long way in the last few decades. Interpreters can now offer remote interpreting services via video and telephone across multiple devices including smartphones, laptops, computers, and tablets. Advantages of new tools and interpretation technologies. New ways of working, greater benefits for professional interpreters, enhanced efficiency for customers. Technological advances have united interpreters and their clients, and it has transformed the interpreting process from something that used to be hassle into a service that's enjoyable and personal. As technology continues to evolve, interpreting will follow in its footsteps. Thank you.